The core of our project starts with the design phase. We started with 4 office space layouts that were designed in Autodesk Revit. We then converted these into 3D meshes and textures so that they could be imported into Unity and then into VR. Using C# scripts from iMotions, we were able to capture user gaze, fixation, saccades, and other metrics, which were used in our analysis. The objectives of this project were to design alternative facility layout options in a virtual reality environment for testing. The virtual reality layouts were completely interactive with the user and were used to test efficiency by assigning tasks and objectives for the user to complete within the layout. We recorded task completion times, recorded eye tracking data, as well as user traffic.
My name is Jake Crowder, and I'm going to be going over the data collection and analysis for our time study. The team was able to implement eye tracking using iMotions. This allowed us to gather user eye tracking data in real time while the user interacted within the VR model. This gave us raw data as well as a screen recording where we were able to go back using the iMotions interface and go frame by frame, identifying where the subject is, what they're doing, where they're looking in order to obtain timestamp data. Doing this, we were able to identify how long it took users to complete each task, as well as how long it took them to fixate on the next objective that they needed to complete. This data was compiled into an Excel file to be used for further analysis in Minitab. These are some figures taken from the Minitab analysis of the walkthrough. We use analysis of variance, or ANOVA, in order to construct a main effects plot with the total time to complete as the response variable. We also conducted a regression analysis between time to fixation and total time to complete to help show that users must be able to identify objectives in order to complete tasks in a timely manner. In our case, there was a strong correlation due to all the layouts being the same size. If you had 2 layouts of different sizes, you might find a different correlation since travel time will be greater for one than the other. But again, in our case, all the layouts were the same size. Therefore, that's why we found a pretty strong correlation. We also see that in the main effects plot that cubicles and workspaces, the variables show a wide variation. So we wanted to see if they were significantly different. And in order to do that, we wanted to conduct a 2-sample t-test. And before we can do that, we must prove that the distribution is normal. And if you look at the probability plot of cubicles and workspaces, you see that for both variables, we have a p-value greater than 0.05. So that tells us that our data is normal. And then if you look at the figure in the middle, that was our 2-sample t-test, and we got a p-value of 0.002. And this tells us that we should reject the null hypothesis that means are the same. So therefore, we can conclude that there is a statistically significant difference between cubicles and workspaces with relation to time to complete.
For data collection and analysis, the heat map shown is used to interpret eye tracking data that we receive from each user walkthrough. Users are compared individually as well as layout based. From there, feedback is provided based on patterns found in the data, and the layouts can be optimized this way.
To test situational awareness, we developed a control room simulation where monitors were arranged on a wall in 4 different configurations. The monitors were either cubed or in a straight line, and they were either symmetrical or asymmetrical. The response variable was total time of fixation. The faster the user could fixate on the target stimuli, in this case lit up monitors, the more situational awareness they had. Results were compiled in Minitab, and the interaction plots show that the symmetrical line configuration resulted in the lowest fixation time. The data was normally distributed, however, we were not able to fit a reliable regression equation. Our R-squared was way too small. This indicates that there might not be a difference in mean times. We asked participants qualitative questions to figure out how they felt about the layout in regards to its spaciousness and ease of navigation. Results were compiled in Minitab, and we found that layouts B and D scored the highest on average. These layouts both have desks, which supports our walkthrough analysis that desks optimize the layout instead of cubicles.
In conclusion, the team was able to prove that it is possible to implement live eye tracking within a 3D, fully interactive VR environment. We also proved that it is possible to interpret eye tracking data in order to find factors that